Hi, I'm APPY SLUIJS, reporting live from the Enjoy This resolution. Today we have another special report for you in our lineup about the amazing science being carried out on this IODP research vessel. A team of internationally leading scientists will explain to you the scientific procedures that are going on the Enjoy This resolution. So what are we looking for? It is all about the search for little tiny organisms. It's much like what my good old friend Mr. Spock once said in a galaxy far, far away. It's life, Jim, but not as we know it.
This is PNN.
Hi, my name is Jay Ping. I'm the lab officer for Expedition 321, and my job responsibility is to oversee the technical staff activities. Right now we're drilling this site. The water depth is about 4,400 meters, so we have about 4,400 meters of drill pipe. Each core is about 10 meters long, and we bring them on the catwalk, and we cut them into about 1.5 meter sections, just for easier handling. And we'll bring the core section into the core lab, and the technician will label them, and then we'll hand it over to the scientists for measurement.
I'm Bridget Wade. I'm at Texas A&M University, and I'm sailing as a stratigrapher. So when we hear the shout of core on the floor, we can dash out and collect the core catcher straight away.
Core's on the floor!
And here we process the core catchers from the cores as they come up. These sediments are composed of lots and lots of microscopic fossils. But we can't see them with the naked eye, so we have to process them to be able to access the microfossils. We're washing the sediments over sieves and also preparing smear slides, and then we will look at the residues under the microscope.
I'm Jan Backman from Stockholm University. I'm one of 7 micropaleontologists on board, and we work with biostratigraphy. We determine the age of the sediment, and we are the first scientists on board that get samples from the cores. Basically what we are doing is that we're looking at the evolutionary history of the different plankton groups. So we can see when a plankton, a certain species evolved and when it died out. And by recognizing which species we have in our slides, we can determine time.
Welcome to the Chem Lab. So down here in the Chem Lab, we analyse solid samples, liquid samples and gas samples from the sediment cores. The solid samples we measure for carbonate, which is calcium carbonate mostly. This is the material that the microfossils, or a lot of microfossils, are made of. And we also measure for organic carbon, so living things, the cells themselves, like you and me. All this information is very useful for directing the further research that will be done on land and understanding what has happened to the sediments since they were deposited. We also have an important function for safety and the gas samples in particular, to ensure that there's no hydrocarbons, so no oil and gas is going to be cored, because we don't have the capabilities to handle that, and that would be a real safety hazard for everyone on board.
My name is Roy Wilkins. I'm a research scientist at the University of Hawaii. I've sailed on 14 of these expeditions, and I really enjoy myself when I do. So this is one of the 1.5 meter long core tubes. This is the way they come off the catwalk. We measure various physical properties of the sediments through the core liners. This measures the density of the sediments. This measures the magnetic susceptibility of the sediments. This measures the acoustic velocity of the sediments. Well, the reason we measure this is so that we can have a sort of a quick look before we actually split the core open to gain an idea of what's inside.
Hi, my name is Steve Hoven from IUP. I'm with the sedimentology team here aboard the JOIDES Resolution. Our job is to take the cores as soon as they're split and describe them in as much detail as possible. We want to get them as fresh as possible to capture it immediately as soon as they are exposed to the air. And so we do that in a number of ways. We visually describe the cores in as much detail as we can see, and then we also scan the cores through a digital imaging scanner and some color reflectance equipment. And then we take small samples of it and put under a microscope for more detailed compositional analysis.
My name's Jim Channel, and we're standing here in front of a magnetometer, which is part of the core flow here in the core lab. And here we measure what are called the paleomagnetic properties of the sediment. And so all the half cores are run through this machine, and if you're lucky, that sediment retains a magnetization from the time when the sediment was deposited. One of the characteristics of the Earth's magnetic field is that it changes polarity from time to time. In other words, the North Pole becomes the South Pole and the South Pole becomes the North Pole. It's like a barcode. We can see that barcode in the core sediments. We can match it to a template and use that to help us to determine the age of the sediments.
When we drill the hole, we take cores, and the cores are about this big, but the hole is much bigger, about that big, because the drill bit is much bigger than the core. So we can then send instruments such as the one that you see here down the hole. These instruments take the same kinds of measurements that are taken by the core, and this is called downhole logging. When we take core, we take it in pieces, and sometimes we miss a piece here and there. They're not complete. But these measurements instead are continuous, so we can use them to join up the pieces of core that we have and complete the record. Once we're done with these measurements, with downhole logging, we can then move to the next hole.